All right, now 11.6 is a little different, but yet the same. This is about heat of reactions. Okay, we learned a difference between exothermic and endothermic. Endothermic is where heat is one of our reactants. Okay, and exothermic is where heat is one of our products. Okay, and usually they show you a heat of reaction at the end of a reaction. So they'll show you calcium carbonate can break down into calcium oxide and CO2, and the heat of reaction is positive 177.8. This implies that this is endothermic. Why is it endothermic? Because we're adding heat. All right. And this reaction is a combustion reaction. Methane plus O2 gives me CO2 and water. It's a negative number, so this implies it's exothermic. Doesn't really not important that much, but if you do take Chem 111, you'll be doing a lot with this stuff. But basically, you treat this number as a stoichiometric amount based on your balance equation. All right, so what does that mean, stoichiometric amount? That means for every 1 mole of CH4, we produce 560.5 kilojoules. Don't worry about the signs, all right? Just do the absolute value. For every 2 moles of oxygen, we produce 560.5 kilojoules. For every 1 mole of CO2, we produce 560.5 kilojoules. All right. For every 1 mole of hydrogen, we produce 560.5 kilojoules. Okay. So these balanced stoichiometric amounts, 1 to 1 to 1, relate to the number that you're given. Okay. So here's a problem. So notice it's a 6 to 6 to 1 to 6 ratio. So this number, all right, refers to these balanced amounts. Okay, so in this problem, calculate the solar energy required to produce 75 grams of this. All right, this is kind of a straightforward problem. All right, so it's 75.0 grams of C6H12O6. Okay, so I got to figure out how many moles this is because remember, this is related to 1 mole of this. So I have to get the molecular weight of this. If you hold on 1 second, I'll figure it out. I'm going to waste time on the video. Okay, so the molecular weight is, what's going on here? I don't know why it says control, but let's just go. 180.18 grams is to 1 mole. All right. Sorry guys, let me see if I can figure out how to get rid of that. Okay. All right, now I'm kind of lost because of all the craziness that was going on. All right, so that's moles of my C6H12, C6H12O6. All right, times, since we're talking about C6H12, 1 mole of C6H12O6 is the 2,803 kilojoules because it's 1 mole of this is to this number. Okay, notice it's still a mole-to-mole conversion. Nothing has changed. So just to kind of show you, you should get So this gives me 0.416 times my 2803. Where's the number? Here it is. 1.17 times 10 to the third kilojoules. So this equals 1.17 times 10 to the third kilojoules. Okay, if I wanted to find out based on the oxygen, this would be I would do a 6 to 1 ratio, or this number right here would be 6. Because for every 6 moles of this, I get 2803 of that. Okay, so I hope this makes sense. Like I said, we'll do more problems like this in class. That is the end of chapter 11. And if you have any questions, we'll talk about it in class.